In this video, I'll go over how to create an OpenRocket file for beginner Rocketry. To get OpenRocket, go to openrocket.info and download the latest version. We're going to be making a rocket capable of an L1 certification flight, so let's get started. First, change the units for your rocket dimensions to inches, right here. The rest can be left as their default options. Click on Sustainer, add your body tube. This is going to be your airframe. We buy these from Lock Precision, so we can search up BT-3.9 by Lock Precision. I'll leave these unchanged. Next, we're going to add our motor tube. So select body tube and then inner tube. This also we buy from Lock Precision, so we can search up BT-1.14. The length of this is going to be 11 inches. And it's going to be offset from the bottom of the body tube by 0.75 inches. Now we go to the motor section and check the box that says this component is a motor tube and click OK. Next, we're going to add our centering rings. These ensure that the motor tube is aligned in the center of the body tube. So click on centering ring. Close. This is a custom cut part. It's going to have a thickness of 0.2 inches. And it's going to be within the airframe by ½ inch. As you can see here, it's going to be contained within the airframe. The material is going to be plywood birch. Click OK. We're going to have 2 centering rings, so select your centering ring and hit duplicate. Edit this. The position of your forward ring is 9 inches. Click OK. Next, we're going to add our nose cone. So select body tube and then nose cone. This is going to be a part that you guys design by yourself. The nose cone shape we will go over in the beginner Rocketry meetings themselves. I'm going to leave it as OJI for now. The length is going to be a maximum of 7 inches, and the diameter is going to be 4. The thickness is going to be 0.1. We're going to 3D print these nose cones out of PLA, so the material is plastic PLA. There's going to be a shoulder on the nose cone, so go to the shoulder tab. It's going to fit inside of the airframe, so it's going to have a diameter of 3.9, a length of 3, and a thickness of 0.1. Click OK. As you can see, the nose cone was generated on the bottom here. We can just fix that by dragging the nose cone above the body tube, like so. Next, we're going to add our fins. So select body tube. For fins, you have 3 options: trapezoidal, elliptical, or freeform. However, for freeform, if you know what you're doing, go for it. But if you don't, then consult one of the leads. We can help you with that. Trapezoidal and elliptical are the default options, or the most basic options. I'm going to select trapezoidal for now. The number of fins is 3. The fin count is 0. Do not change these. The root chord, tip chord, height, sweep length, and sweep angle, we will explain in the meetings. For now, I'll just go with random values. The position, let's do the fins first. The fin tabs first. So let's go to the fin tab section. The tab length is going to be 6. Tab position is 0. Tab height we can calculate automatically. This changed my tab length, but it's set to 6 and 0. So I got a height of 1.395, which just ensures that the fin tabs actually attach to the motor tube within the airframe right here. So because we did the fin tabs first, I see that the fin tabs actually intersect the centering ring right here, which is not how it's going to be in real life. So I can change the position of my fins. I'm just going to do 1 inch within the body tube for now. Also, with your fin positions, you want to make sure that the trailing edge of your fin does not exceed the bounds of your body tube. The material is going to be plywood birch. We're going to attach the fins using epoxy adhesive to the airframe. Epoxy, we're going to do that by filleting the epoxy on the outside around your fins. It's going to have a radius of 0.5. OpenRocket doesn't have epoxy as one of its materials, so we're going to go with the next closest density, which is plastic acrylic. The fin thickness is going to be 0.2. And click OK. Next, we're going to add mass components for the different parts of the rocket. First, we're going to add an epoxy mass component for the adhesive that we use to attach the fins to the rocket. It's going to have a mass of approximately 40 grams. The length is going to be the same as your fin tab, and the diameter is going to be 3.9, the internal diameter of the rocket. And the position is also going to be the same as your fin tabs, so -1. Okay. Next, we're going to add a mass component. So select body tube. This mass component is your motor retainer. This helps retain the motor inside your motor tube. Make sure that it doesn't fall out during your flight. It's going to have a mass of 10 grams. And it's going to be at the same position as the offset of your motor tube. So 0.75 from the body tube. Okay. Next, we're going to add a mass component for your eye bolt. This attaches the shock cord to the rocket itself, and your shock cord is going to be attached to the parachute. So your eye bolt is going to have a mass of 20 grams, and it's going to be in the same position as your forward centering ring. So from the bottom, -9. It's also going to be off, not in the center of your rocket. It's going to be closer to the edge. So we're going to change our radial distance to 1.2. Okay. Next, we're going to add our mass component for the quick link. Your quick link attaches your nose cone to the shock cord. It's going to have a mass of 20 grams. And it's going to be in the same position as the bottom of your shoulder. So 3 inches from the top. Click OK. So these are all the mass components in the rocket. Next, we're going to add our parachute. So select body tube and then parachute. Our parachutes are going to be 28 inches in diameter. We can search up LP-28-2022. The diameter and the shroud lines do not change these. The location of the parachute is going to be approximately 5 inches from the top of the body tube. And it's going to be packed tightly inside of our body tube. So we're going to have a length and diameter of 3.9. And it deploys at apogee, which is the highest altitude of your rocket. Click OK. Next, we're going to add our shock cord. Our shock cord attaches our parachute and nose cone and rocket together. It's going to have a length of 15 feet, so change the units to feet and a length of 15. The material is going to be tubular nylon 7/16 inch, and it's going to be approximately 10 inches from the top of the body tube. Okay. These are all the components of your OpenRocket file. Next, we're going to do some simulations to calculate the delay charge of the motor itself so that your parachute is deployed at the right time. So for that, we're going to add motors to the rocket. We have 3 options for motors. The H135W. This one has a white flame. Next is the H182R. This one has red flames. and the H195NT. This one has blue flames. The numbers in the names of the motors represent their maximum thrust, or I'm sorry, their average thrust. So higher number, higher thrust. But if we go to the simulations and run these, it's going to show you the different apogees for the different motors, and it's approximately like similar for all of these. So it just comes to personal preference of color, whichever one you choose. As you see here, the optimum delay for all of these motors is close to 8. We can only do like positive even integers. So 8 is going to be the motor delay for most of you guys. You can also edit these simulations to be closer to the launch conditions of the launch site itself to get a more accurate representation of your flight. But for now, this is a basic overview of OpenRocket and creating your first OpenRocket file. You're going to save these and submit these when applications open up.